Hello, my name is Taylor Cole, and I'm doing my last molecular diary on lidocaine. The first thing that we're going to talk about is the structural features in lidocaine. As you can see, I only had my 3 functional groups that I've gone over on the last 2 diaries. This aromatic ring is nonpolar, so that doesn't affect my basicity or my acidity. Over here, my amide, it does have a nitrogen in it, so you would think it was a base, but because of its resonance that we will learn in organic chemistry, its lone pair and its resonance structures don't allow it to accept any protons from acids, so therefore an amide is not a good base or acid. But my tertiary amine over here is considered a weak base structural feature, so because of that amine, I would consider lidocaine a weak base. Some ways that it's used in society is the first one, which is the reason why I picked it, is its topical use. Like I said, I suffered from a back injury in high school, so I would use icy hot patches and different creams which all contain lidocaine in it. Lidocaine can be used as a topical cream that you rub on your skin. An important feature that allows it to be used this way is its low melting point. Because of that, it allows it to stay in that cream-like state and not like it's rubbing like a solid onto you and you're not rubbing liquid onto you. It is a cream. So its low boiling point and melting point helps because of that. It gets its low melting point from its dispersion forces because it is nonpolar. It only has dispersion forces. And that allows it to have that low melting point because it does not take a lot of heat to break these bonds within it. The next thing that's used is local anesthetic. It is injected into any part of the body that you're having either surgery or a procedure on, and it numbs that part of your body, cutting off any signals from your brain to those pain receptors in your leg. It is used in its hydrochloride salt state in this because it's a little bit less potent. It does make it soluble in water, however, so like when you're injecting it into your body, you want an insoluble substance going into your body and not being able to dissolve and go into your blood. So that is an important factor that helps that be possible in the local anesthetic. It also treats heart problems such as ventricular tachycardia. Ventricular tachycardia is when you have irregular heart rhythms, and they do inject lidocaine into the IV into your veins, so that's how it's also injected into you, again in that hydrochloride salt state and not the free base state. And the last one is an epidural. An epidural is injected into your back as a spinal block, and it makes from your waist down numb. It's used for mothers during labor. It is again in the hydrochloride salt because it is getting injected into you and you do want it to be soluble in your blood. Another important feature that I think lidocaine has is that it has only a half-life of 120 minutes, so an hour and a half to 2 hours. This is important because you wouldn't want you to have like no function over your legs for 3 days as it wears off. So having a shorter but long enough half-life to get procedures done is important. And it also wears off, and it doesn't just automatically stop. It will wear off as the half-lives continue to progress, so you will gradually get feeling back into that body part. The last thing that we're going to talk about is how this weak base affects its uses in these different ways. Because it is a weak base, it won't, and it's not an acid, it won't tear away at your skin when you're applying it on a topical use. If you're applying like an acid substance, it will disintegrate your skin, which it wouldn't be good. And then if you're injecting it into your blood is basic, so you don't want to be injecting an acid into it because it can eat away at different structural components of your like skin and your body and your organs, so you don't want an acid being injected into you, which is important. And other than that, thank you for watching my molecular diary on lidocaine. Thank you very much.